Welcome to a world where the physical and digital merge seamlessly. Today, we're diving into the concept of digital twins. A digital twin is a virtual model of a physical object, system, or process that allows us to monitor, simulate, and predict real-world behavior in near real time. While the concept has been around for years, it has gained traction with advancements in AI, machine learning, and the Internet of Things, IoT. Originally used in aerospace for simulations, digital twins now span industries like manufacturing, healthcare, and city planning. So, why are they important? Digital twins provide a smarter way to manage resources, predict system failures, and optimize operations. They allow us to simulate real-world events and make data-driven decisions before they happen. In this video, we'll explore how digital twins work, their real-world applications, and how they're transforming industries. Stay tuned to see how this revolutionary technology is shaping the future. So, how do digital twins actually work? At the core, they rely on real-time data, IoT sensors, and advanced algorithms to create an accurate virtual representation of a physical system. Think of it as a mirror image. Every movement, operation, or change in the physical world is captured and reflected in the digital twin. It all starts with IoT sensors. These sensors are embedded in physical assets, constantly collecting data on things like temperature, pressure, motion, or even user behavior. This data is then transmitted to the digital twin, where AI and machine learning algorithms analyze it in real time. The result? A dynamic, constantly updating model that doesn't just reflect the current state of the physical system, but can also predict future outcomes. For example, in manufacturing, a digital twin can forecast when a machine is likely to break down based on wear and tear data, allowing for predictive maintenance rather than costly, unplanned downtime. What makes digital twins truly powerful is the continuous feedback loop between the physical and digital worlds. This means any changes made in the real world are instantly reflected in the digital twin, and vice versa. You can test new strategies, optimize performance, and foresee potential failures before they happen, all within the virtual model. By simulating real-world scenarios, digital twins empower businesses to make more informed, data-driven decisions before they act in the physical world. Digital twins aren't just a futuristic concept, they're already being used across a wide range of industries, driving innovation and efficiency. Let's take a look at some real-world applications. In smart cities, digital twins are used to monitor and manage urban infrastructure. Everything from traffic flow to energy consumption can be simulated and optimized in real time. This allows city planners to address issues like traffic congestion and resource allocation, all while reducing environmental impact. In manufacturing, digital twins are revolutionizing production lines. By creating a virtual model of a factory or machine, companies can simulate different processes, identify potential bottlenecks, and predict equipment failures before they happen. This results in smoother operations, less downtime, and significant cost savings through predictive maintenance. In healthcare, digital twins are helping doctors and researchers personalize treatment. Imagine having a digital replica of a patient's organs, allowing surgeons to practice complex procedures before the real surgery. This not only reduces risks, but also helps improve outcomes in critical medical treatments. And it doesn't stop there. Aerospace companies use digital twins to simulate and test new aircraft designs before they're built, and energy companies use them to optimize wind turbines and power grids. From cities and factories to hospitals and airplanes, digital twins are transforming how we plan, predict, and optimize in the real world. Their ability to simulate and solve problems virtually is unlocking new levels of efficiency and innovation across industries. For industry professionals, the benefits of digital twins are game-changing. Whether you're in manufacturing, healthcare, or urban planning, digital twins provide tools to work smarter, not harder. One of the biggest advantages is cost reduction. By simulating systems in real time, you can predict when equipment might fail, allowing for predictive maintenance. This reduces downtime and avoids costly, unplanned repairs. Digital twins also enable faster decision-making. Real-time data and simulations allow professionals to experiment with different strategies and immediately see the outcomes. This level of data-driven decision-making improves efficiency and cuts down on trial-and-error processes. In product development, digital twins significantly reduce time to market. Prototypes can be tested in the virtual world, eliminating the need for multiple physical iterations. This streamlines the design process and helps companies deliver new products faster. For engineers and city planners, digital twins can simulate real-world scenarios, such as traffic patterns or energy consumption, helping them create more sustainable and efficient solutions. Ultimately, digital twins give professionals the ability to optimize performance, reduce risks, and make more informed decisions. Whether they're running a factory, planning a city, or performing a complex surgery, the ability to visualize, predict, and improve processes in real time is transforming industries, one digital twin at a time. At the heart of digital twins are two key technologies: artificial intelligence, or AI, and the Internet of Things, known as IoT. Together, they drive the real-time data processing and intelligent decision-making that make digital twins so powerful. IoT plays a critical role by connecting physical assets to the digital world. Smart sensors embedded in machines, buildings, and even vehicles constantly collect data on things like temperature, movement, and performance. This data is then transmitted to the digital twin, creating a live, up-to-date model of the physical system. That's where AI comes in. With so much data being gathered, AI algorithms help analyze and make sense of it. AI can spot patterns, predict outcomes, and even optimize processes without human intervention. For example, in manufacturing, AI can use data from the IoT sensors to predict when a machine is likely to fail, enabling preventive action. Machine learning, a subset of AI, takes it even further. The digital twin can learn from the data over time, becoming smarter and more accurate in its predictions. This allows digital twins to not just mirror the current state of a system, but to anticipate what's coming next. The combination of AI and IoT makes digital twins a dynamic tool for real-time monitoring, optimization, and predictive analysis. They transform raw data into actionable insights, helping industries solve problems before they even occur, and pushing the boundaries of what's possible with digital twins. As digital twin technology continues to evolve, its future potential seems limitless. We're already seeing its impact in industries like manufacturing, healthcare, and smart cities, but the possibilities stretch far beyond. One area with massive potential is space exploration. Imagine using digital twins to simulate entire space missions, testing spacecraft and equipment virtually before they ever leave Earth. This could drastically reduce the risks and costs of space travel, opening up new frontiers for exploration. In climate modeling, digital twins could help us simulate environmental changes and predict the impact of human activities on the planet. By creating virtual models of ecosystems, we could find more effective ways to tackle climate change and manage natural resources. Global supply chains could also be transformed. Digital twins would allow companies to simulate and optimize logistics on a massive scale, reducing bottlenecks, cutting costs, and improving efficiency in international trade. But despite all this potential, digital twins come with challenges. One major issue is data security. With so much real-time data being collected, there are concerns about protecting sensitive information and ensuring privacy. Additionally, high implementation costs can make it difficult for smaller businesses to adopt the technology. There's also the complexity of creating and maintaining accurate digital replicas, which requires significant expertise and resources. While these challenges are real, the future of digital twins is incredibly promising. As AI, IoT, and data management technologies continue to advance, we're likely to see even more innovative applications that push the boundaries of what digital twins can do. Digital twins are no longer just a concept of the future. They are revolutionizing industries today. From smart cities and manufacturing to healthcare and space exploration, digital twins allow us to visualize, simulate, and optimize the world around us in ways that were unimaginable just a few years ago. By leveraging real-time data, AI, and IoT, we can predict and prevent issues before they happen, streamline processes, and make smarter, more informed decisions. The ability to create these virtual replicas has already transformed industries, and the future holds even more promise as technology continues to evolve. However, as with any technological leap, challenges remain, particularly around data security and implementation costs. But the benefits far outweigh the hurdles, and the potential of digital twins to reshape the way we work and live is truly groundbreaking. Thank you for joining us in exploring the exciting world of digital twins. If you found this video insightful, be sure to subscribe for more deep dives into the cutting-edge technologies shaping our future. The digital twin revolution is here. Are you ready?